All right, good afternoon. Thank you for joining me today. I'm pleased to tell you about how SharePoint Online secures customer content in the cloud. My name is Matt Swan. I've been an engineer in the SharePoint organization for 12 years. I joined Microsoft right out of university after Cal Poly, joined the SharePoint org, and for 10 of those 12 years have been dedicated strictly to security engineering. First on the on-premise platform, doing the security development lifecycle, teaching our developers how to find bugs, prevent security defects from being introduced. And then on the cloud security platform, increasing the hardening that we have in the cloud and building mitigations and detections to detect any evidence that there's a threat actor in the service and to build incident response to kick that individual back out. But the things that I'm going to tell you about today aren't just my team's work. Security in our org is an organization-wide focus. So we have a culture of customer obsession from end user delight all the way down to security and privacy. And our engineers, all the way through our leadership, believe that earning and maintaining your trust is their job. So I'm pleased to tell you today about the work that they've done. And it's my considered opinion, well-informed opinion, maybe even, that our cloud is the safest place for your data. And I hope that by the end of my talk, you'll agree. So I want to talk through 5 principles today. First, in our service, your data remains yours. Second, your data is protected in transit and at rest. Third, we administer the service without access to your content. Fourth, our security is continuously validated. And fifth, our security is externally audited to show that we don't just talk the talk, we walk the walk. So let's talk about how your data remains yours and what that means. When you upload content to SharePoint Online, Microsoft is the data processor. We're the custodian, but ownership remains with you. And we're transparent about what that means for us. For example, if we receive a subpoena to turn over content from SharePoint Online that belongs to you, we try, to the extent that we're legally able to redirect that subpoena back to you because you own that data. It's not ours to give up. If you choose to leave the service, that data can come with you. We don't want to block that or make that difficult. And we never mine your data for advertising purposes. Now, the security boundaries and features that we implement are driven by a desire to respect the privacy of that data that you've entrusted with us. But that security goes beyond simply confidentiality. We also think about how to protect the availability and the integrity of your data. And wherever possible, we don't just make policy decisions and send an email to the organization. We back those policy decisions up with technology to control access or to enforce those policies. And we back that enforcement up with monitoring to make sure that those policies are remaining compliant. One of the things I love about Office 365 is the transparency that we give our customers on the Office 365 Trust Center. And here's where we answer questions that you should be asking about any cloud service provider before you choose to trust them with your content. Questions like where your data is stored, who has access to your data. If the cloud service operator does or does not have access, do you have any way of knowing when they access your content? What compliance certifications have they received? What guarantees do they make about privacy? So those are the policy underpinnings of the security that we do. And for the rest of the talk, I want to dive into the technical implementation of these policies. So where we start here is by protecting your content in transit and at rest. So security starts on your device when you choose to upload content to SharePoint Online. We encrypt that transmission with TLS 1.2, a 2048-bit key, and perfect forward secrecy. Now, the use of perfect forward secrecy is extremely important. This is a key exchange protocol that ensures that if a malicious adversary or a threat actor were listening to communications between your device and the SharePoint Online service, and he's recording everything that he sees, and then at some point he gains unauthorized access to our SSL certificate. He can't use that SSL certificate to decrypt previous communications between you and our service. He can only decrypt them moving forward. That's the forward part of perfect forward secrecy. And so this is a best-in-class, kind of an industry standard way of protecting content in motion. We do support TLS 1.1 and 1.0, for devices that maybe need backwards compatibility, but when your device negotiates a protocol with SharePoint Online, it will choose the best one that it supports. Furthermore, once that device has connected to SharePoint Online, we ensure that it only connects to us using HTTPS, using TLS. And we do that in two ways. One, we don't accept authenticated traffic over a non-HTTPS URL. And second, we use a browser header called HSTS to ensure that it never even attempts to connect to us over HTTP. And so this prevents DNS redirection or man-in-the-middle attacks when you're using an untrusted network, for example, browsing from Starbucks. Finally, when your content moves through the service from one data center to another, just like we protect your content from a man-in-the-middle between your client and our service, we use the same protections between a data center and another data center that Microsoft operates. So we use encryption in transit there as well, anytime that your content is moving. Now for protection at rest, we take a defense-in-depth strategy because we believe that a layer of defenses to guard against different threat profiles, different types of weaknesses, is our best defense here. It's the best strategy. And so this encompasses security at the physical layer in the data center, security at the network layer with our network ACLs, our Active Directory domains, protection at the content layer, protecting the devices that hold your content and the logically encrypted files that live there. We defend the application using the security development lifecycle, and we control access. So first, let's talk about physical security. Microsoft runs a world-class set of data centers that are spread all over the globe. And even though I'm a security engineer in the SharePoint Online organization, I can't take my badge, go to a data center and swipe to get access to the machines that I administer. Access to these data centers is restricted only to essential personnel. And in order to be on site, they need to go through multiple factors of authentication to prove that they are who they say that they are. Now, once they're in, we have on-premise security officers and motion sensors, video surveillance, all to ensure that they're only performing actions that they're authorized to take, and that we have a forensic record of anything that might go awry. Additionally, as I build intrusion detection within the service, I'm on the lookout for anomalous activity by those same data center engineers. So for example, if a USB device were to be plugged into a physical machine that's under my control, I would receive an alert, because that's activity that I don't expect, and it might indicate attempted access to customer content. Now similarly, our service is fault tolerant and highly available, and we do this by taking 2 copies of your content and distributing it among 2 data centers in the region that you signed up for with Office 365. We do this to respect your data locality while also guarding against, say, a natural disaster or the loss of internet connectivity to a data center, or maybe a service impacting change that negatively impacted your access to data. In that case, we can change the DNS entry that points to your customer domain, point it to the other data center that stores your content, and restore access. Now, the last thing in the world that we ever want to happen is to lose data. And so we also have a strict policy around content backups. While you are using the service, in the back end of the service, we are constantly taking backups of SharePoint's content databases. Those backups are stored in a read-only location for 14 days. We have 5-minute granularity on the data that we're backing up. And so if something catastrophic were to happen, for example, one of your employees or a customer were to make a change that you can't revert back from, or you think you experienced data loss, you can call Microsoft support, and we can restore your content back to any time in the last 14 days. Because your content is yours. We never want to lose it. Again, on the theme of transparency, the Trust Center shows you specifically where our Microsoft data centers are and which ones store your content. So you can see we have pairs of data center in North America, in Europe, in East Asia. We have regional data centers in locations like Germany, and we continue to update this map as we expand to new locations. Now, those physical machines are connected to a network, so how do we isolate them from unauthorized access? So we start with router ACLs. Every time a subnet is assigned to the SharePoint Online data center, we use router ACLs to limit unauthorized access into or out of that network location. In some cases, we apply additional ACLs using host-based firewalls for defense in depth. And we never take one of our back-end or front-end machines and connect it directly to internet traffic. we always route that through a load balancer. So that helps from a security perspective to ensure that only authorized ports and protocols are reaching those machines. And it helps with availability as well, because it means that if one of those machines experiences a blip or needs to be rebooted, other traffic will be routed across the other machines in that availability group that are still healthy. Now, these machines on the network are joined to an Active Directory domain. We apply a principle of isolation here as well. So SharePoint Online's Active Directory domain has no domain or forest trust with any other domain within Office 365, within Microsoft's corporate network or Microsoft's network backbone. Additionally, we have no trust between test and production. And even our production environment, we split into smaller domains with no trust amongst each other. And that helps us protect against smaller fault zones. It helps us do better isolation from a security perspective. And it's also easier to manage smaller Active Directory domains. But what about content security? So we've locked down the network, we've locked down physical access, but your content is still sitting on a hard drive somewhere at rest. So we take two defenses here. First, we enable BitLocker on any volume that stores your content. And this means that if that hard drive were to be removed from the server where it's physically present, those bits are no longer able to be decrypted. It's essentially an empty drive at that point. Your content is unrecoverable. We also apply logical per-file encryption so that an engineer who has interactive access or the ability to run scripts on the machines where your content is stored, they don't have access to your content either. So the way this works is we take each file and we encrypt it with a unique key. For large files, we split them up into smaller chunks. We give each one of those chunks its own unique key. And then we store the keys, the pieces of your file, and the access control certificates for access to Azure storage, where those encrypted blobs are stored, and distribute them in 3 different locations. And then the key that we use to access Azure only allows read and add. So this prevents a data destruction attack, where someone might want to, with unauthorized access, destroy the data that we've stored in Azure Blob. So here's a walkthrough. Here's a document that a customer uploaded to SharePoint Online. And I want to distribute this across these 4 Azure storage containers. So I'm going to take this document, split it into 4 pieces. I'm going to assign each piece a unique encryption key, encrypt the contents, and then I need to unlock those Azure storage containers from the SharePoint Online key store. Next, I'm going to distribute my encrypted contents across those 4 storage containers. I'm going to take a master key, which I'll talk more about in a minute. I'm going to encrypt those per-file encryption keys and store them in SharePoint's content database. So now I have 3 different locations that an attacker would need to compromise in order to gain unauthorized access to customer content. If he only has access to Azure, then he has a bunch of encrypted blobs, and it's kind of like BitLocker. He doesn't know how to recover an individual file, how to decrypt an individual file, or even how to piece them back together. If he only has access to SharePoint's content database, then he knows the metadata about the files, and he has encrypted encryption keys, but he can't decrypt them and he can't access Azure. And likewise, if he only has access to SharePoint's key store, then he doesn't actually have access to the content to put things back together. That master key, that key number E at the end of the slide, is part of a new initiative that we're rolling out called Bring Your Own Key. Now this adds an additional master key that protects, it's the root of trust for the per-file encryption keys. And if we lose access to that key, we can no longer access your content. And what I love about Bring Your Own Key is that you own the master key. You can create it in an Azure Key Vault subscription that you own. You can store that in a hardware security module if you choose. Azure Security and Azure Key Vault supports that. And you get to grant access to that key to Office 365. If you remove access or revoke access, we lose access to your content. There's no backdoor. This is unrecoverable for us. This is coming as a preview at the end of this calendar year, and it'll be rolled out to be more generally available in 2017. And so I believe that this gives you an unprecedented level of control over SharePoint Online's ability to access your content. So your content is stored in SharePoint Online, but how do we make sure that the features that we build in SharePoint gate access appropriately and only allow authorized end users to access your content? The way that we do this is by incorporating a security development lifecycle into our engineering organization. So this starts with my team. I partner with engineers to do security design review and threat modeling, to evaluate their designs against security best practices. I work with our privacy and compliance experts to make sure that their designs respect your privacy and abide by the compliance controls that we need to continue operating in regulated markets. I arm my engineers with secure coding and testing practices to make sure that they know how to avoid mistakes and how to catch them before they ship. And then I work with the Office 365 Red team to understand my system holistically to look for weaknesses where I might want to put more engineering effort. But we believe that even though we're doing a great job internally as engineers on the security development lifecycle, that security is better when it's a community effort. And so we participate in Microsoft's online security bug bounty to bring in external engineers and invite them to find vulnerabilities in SharePoint Online. So the way this works is an external researcher might choose to look for bugs in SharePoint Online or Exchange or maybe Skype for Business. And if he finds a security defect in SharePoint Online, he reports that to Microsoft's Security Response Center. The Security Response Center engages me and engages the engineer who owns the component where the defect has been identified. We work together to understand whether this is a real defect, whether it really does put customer content at risk, whether it really is exploitable. We develop a patch. We test the patch. We ship it to a small set of customers first. We gradually roll that out to 100% of our customers to protect them all. And then we tell the customer, thank you, we fixed your issue. We give them a monetary reward. We publish their name and give them credit on our online services Bug Bounty Hall of Fame. And then we allow the customer to talk to the researcher to talk to other researchers about what he found. And so we believe that this gives us the best of both worlds. On the one hand, we have a whole world's worth of security engineers and security researchers who find great, really tricky bugs in SharePoint Online that we may not have found ourselves. And on the other hand, because they've reported it to us responsibly, once we have fixed the issue and customers are no longer at risk, they're able to share what they found with the rest of the security organization, the rest of the community, to help them learn how to find similar bugs. And so it's a rising tide lifts all boats kind of situation. And we're happy to engage the community and support their research in Office 365 in this way. So your content is secure at rest. It's defended in physical data centers. But do we, as Microsoft Cloud operators, have access to your content? I want to start by telling you how we operate the data center, and then I'll get into the answer to that question. Most of our actions in the data center go through a PowerShell console that we call Merlin. And so without interactively logging into the data center, from my corporate machine, I can launch PowerShell. I can restart IIS on a machine. I can locate machines that are grouped into certain roles if I need to. Now, not everyone has this ability. The engineers only have this if they have specific business reasons. For example, they're part of SharePoint Online, or maybe they're a partner service that ships features in our data center. And if they need to make a state-changing operation, like restarting IIS, that requires two-factor authentication. So they insert their smart card into a reader, they type in their PIN, they prove that they are who they say they are before they can take that action. And of course, we maintain an audit trail for all of these operations. Now, we don't just limit our engineers to pre-canned scripts that they can run in our data center. We also allow them to react rapidly to new or changing conditions while still remaining in this Merlin tool. And so we give them the ability to write joblets. And a joblet is a script that is code reviewed, manager approved, checked into our source control system, and then rapidly synced to the data center in less than an hour so that this engineer can run that command through Merlin, again, without interactive logon. So this kind of gives us the best of both worlds. We can respond to maybe a break-fix activity or a support call that we've never seen before, yet we keep our engineers on the rails, so to speak, performing scripted activity through the Merlin console. So here's kind of what that looks like. I have an engineer, and he needs to restart a machine in the data center. Now, that's a state-changing operation, so he's going to insert his smart card and do two-factor authentication to Merlin. Next, Merlin is going to go to its script library and find the script that's associated with this action, and then it'll run that script on that remote machine on the engineer's behalf without him ever having to interactively log in. Now, perhaps my engineer does need to log in for some reason. He needs interactive access. For some reason, joblets don't work. We've coached him through it, but he's like, no, 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 I really need interactive access for this case. He doesn't actually have the ability to do that because we abide by a policy of zero standing access. So this means that at any given time, no engineer by default ever has access to interactively log into our data center. We do maintain a set of, in case of emergency accounts, in case our Merlin workflow system goes down, but those accounts are instrumented in such a way that my team, the security team, receives a phone call within 5 seconds if that account is ever used. And so our engineers know not to use this. In the cases where they do, our team doesn't own the workflow engine, but yet we're still receiving phone calls as they continue to use these accounts to get that system back online and then log out of the data center. So there's essentially no backdoor here that can be used without our knowledge. So in the case where an engineer does need interactive access, he requests elevation using a Merlin command. Merlin kicks off a workflow that evaluates that engineer's privileges, the access level that he asked for, that might ask for manager approval, or in a regional data center, it might ask for the authorization of operators in that region. Once that's been approved, my engineer gets a new password, and he gets time-limited access. So that workflow is going to come back in a set of hours and disable that account, terminate any of this engineer's interactive logon sessions, and return him back to his previous state. So here's my engineer again. He did two-factor authentication, logged into Merlin, and said, I'm requesting interactive access. The first thing that Merlin will do is evaluate this engineer's entitlements. So we're going to find out whether this engineer is up to date on his security training, whether he's passed a background clearance, whether he has passed fingerprinting, depending on the type of data center or region that he's logging into, and perhaps whether he's even allowed to request this entitlement. If all of that passes, then the next thing we're going to do is we're going to email this engineer's manager and ask her whether this engineer has a business justification to request interactive logon. If she signs off, then the workflow will create an account for this engineer, and this engineer will use that account to gain time-limited interactive access to the data center. When his time is up, the workflow engine disables his account, our security agent terminates any interactive logon sessions that he has running throughout the environment, and he's back to ground zero. On the basis of this workflow engine, we built the next big feature, Customer Lockbox. Customer Lockbox ensures that our engineers never have access to customer content. Their JIT accounts, their just-in-time accounts, don't have access. Our standing access in case of emergency accounts don't have access. Our engineers don't use service accounts to perform their activities because they don't have access to the service account credentials. We built the system. Those account credentials are encrypted at rest. We have access to the logs that show whether engineers are using this. We monitor for things like an engineer switching credentials from their just-in-time access accounts to a service account. And so we monitor for this activity just like we monitor for unauthorized threat actor activity inside of our data center. In the exceedingly rare case that an engineer would need to do this, they would write a joblet and tag it as a customer content joblet. The execution of that requires an extraordinary level of business justification and manager approval. And it runs through the same workflow system that the rest of Merlin uses. But what I love about Customer Lockbox is that it puts you in the approval process. If Microsoft engineers need access to your content, you can opt in the Office 365 portal to be part of that approval process. As a tenant administrator, you'll receive an email saying that Microsoft is requesting access to your content for this reason, and if you don't click approve, that's it. There is no backdoor here. I cannot access your content without this. And then whether you've chosen to opt into approval or not, we will always generate an audit event for each of these elevation requests. And that's present both in the Office 365 portal, in the audit log, as well as in the management activity API that we expose to you so you can incorporate it into your own security monitoring infrastructure on-premise. So here's a Microsoft engineer, and he received a support call from a customer who uploaded or created a document in his OneDrive for Business. And once they had created that document, they get an error when they click on it. They can't download it, they can't access it, and they believe that this issue has something to do with the content of this document. So they call Microsoft, they open a support case, And they say, Microsoft, I authorize you to retrieve the contents of this document so that you can investigate the issue, do some troubleshooting, fix the issue so that I can regain access to my content. So my engineer tries different things. This really looks like the only way that he can resolve the issue is with access to the document. So he opens up Merlin, does two-factor authentication, and starts a customer content joblet to retrieve that document. Now, Merlin looks at the script and realizes this is a customer content joblet. So the first thing I need to do is email this engineer's manager. She's going to work with him to ensure that there is no other option but to run this customer content task, right? I can't overemphasize how seriously we take this. I realize maybe it feels to you like a black box, but as a Microsoft engineer, the last thing I want is to have to access your content. So if she has worked with this engineer and there is no other way to make progress on the support case except by retrieving that document, she will approve. The next thing that's going to happen is the workflow will email the tenant administrator for this customer, for this organization, to ask them whether they're willing to approve this customer content task. Now, the tenant administrator is familiar with the support case that his user opened, so he's going to sign off. We will generate an audit event for him. And then this workflow will retrieve the document from SharePoint Online, return it back to my engineer. The engineer is going to use it to investigate and resolve the issue, and then that document will be securely deleted. So just like Bring Your Own Key gives you an unprecedented level of control over Microsoft SharePoint Online's access to your content, this gives you a similar level of control over our operators' access to your content. And I'm proud to say that since we built this feature in April, we've never had a need to use it. We've had 0 cases of customer lockbox execution. And in fact, before building this feature, I'm not aware of any time that we've needed to access customer content. What we did with customer lockbox was turned it into not just a policy, but a set of technical controls and a set of monitors to ensure that we've remained compliant with those controls. And so that we can tell you confidently that this is a thing that never happens. So that's all well and good. We've built lots of features over the last weeks, over the last months, over the last years. But how do we know that today, on a Tuesday in September, that our security is as good as we think it is? Configurations drift, right? So the first thing we start with is configuration scanning. We have a set of scripts called the patch train that run continuously through our environment, checking the patch state of every machine, checking our antivirus signatures, ensuring that every machine meets a configuration baseline. Now, sometimes we need to apply patches and reboot the machine, and we want to do that in a way that doesn't impact reliability or availability. So we've written role-specific logic to allow us to reboot SQL servers and domain controllers, front-end machines, without you noticing, without introducing any interruption in our service. And of course, we patch new servers before those are brought into the environment. So that's our inside-out scanning. We also scan from the outside in to make sure that those router ACLs that protect the network subnets that are assigned to SharePoint Online are solid, are locked down. So we do port scanning from Azure, from Microsoft's corporate network, from our corporate backbone as well, to make sure that none of those locations exposes unauthorized access to the SharePoint Online network. Now, if you've ever worked at cloud scale or administered a large fleet of Windows machines, you've probably learned that inventory is one of the necessary prerequisites to being able to accomplish this task. So a partner team within our organization built a really neat tool called Snapshot to solve that problem. So the first thing they do is they ping scan every network location that's assigned to SharePoint Online. And every time they find a device that responds to ping, they make a note of that IP address and they find out whether it exists in our inventory system. Does it exist in Active Directory? And does it exist in our workflow inventory? If it does, then they check our remote administrative ability on that machine. Can I log in with remote PowerShell? Can I execute commands via WMI? And if I can, then I'm going to check our security agents next. Going to make sure that our telemetry agent is present, our security agent is present, management agents are all present, installed, and running. But just because a Windows process is running doesn't mean that it's performing the tasks that we expect it to do. So for each of those, they communicate with a cloud telemetry endpoint. we're going to log into that telemetry endpoint and make sure that it's receiving heartbeats from those agents within the last few minutes to make sure that it really is alive. If all of that checks out, I'm going to move on to checking the patch status, making sure that it's compliant, that the baseline is good, that AV patches are applied. So this helps us look for known unknowns, right? Maybe we have a machine that's missing a patch, maybe we have a router ACL that drifted, or an agent that's not running. But to borrow a phrase, how do we find unknown unknowns? And that's the job of the Office 365 Red Team. Personally, I think these guys have the most fun job of anyone in Office 365. Their job isn't just to find vulnerabilities in the service. Their job is to exploit those vulnerabilities to gain access to our production data center without touching customer content, because they abide by customer lockbox as well. And so they take a no-holds-barred approach. They study real-world threat actors. They read breach reports. They learn what tools they use. They go to security conferences. They bring those tools back, and they apply them against us. If it takes weeks, if it takes months, they study our source code. They study our bug database. They talk to our engineers. We give them design presentations. They find any way in that exists. And we love that because it teaches us new things that we didn't know existed. It helps us identify weaknesses that we need to shore up. And it helps us practice incident response against best-in-class adversaries before we have to do that in the event of a real adversary being present. Just like a real threat actor, they seek to evade our detective capabilities. They try to remain persistent and implant themselves in our data center. And they try to avoid our incident responders. But every red team needs a blue team. And so while the Office 365 Red Team is shared among Exchange, Skype, Skype for Business, SharePoint Online, the blue team is my team. We cover OneDrive and SharePoint. Now, I mentioned that I've been at Microsoft for 12 years. I've grown up in the SharePoint service, and so have most of the engineers on my team. And so we apply this deep knowledge of the service to the job of protecting your content against unauthorized access. So my engineers are dedicated to prevention, detection, and recovery. And we don't just work alone. We actually work across Microsoft to advance the state of the art. And this means many of the techniques that we've pioneered, we've driven into other teams, shared with other teams like Azure, kind of Microsoft's online corporate network. We've shared them with teams like Exchange Online so that they can all benefit from these techniques as well. And then we also work with teams like the Defender Advanced Threat Protection Group to bake some of the techniques that we use to defend our internal network into products that you can take advantage of in your own corporate network. Now, we take a threat-focused methodology, which means that our bread and butter is studying threat actors and understanding which ones are likely to attack us or our customers, what tools and techniques they use, running those same tools and techniques in our data center, and looking for the evidence that gets left behind. And I say this because many organizations, when they try to solve intrusion detection, start with an anomaly-focused methodology. In an anomaly-focused methodology, I take whatever telemetry is coming out of my service, and I run it through an anomaly detection algorithm, often using machine learning. And when I find anomalies, I display those to a set of operators or a set of analysts. They dig into these and try to understand whether this represents a compromise of the service. But this suffers from a couple of key defects. One, in any cloud service of reasonable scale, you will have anomalies every day. Every time you deploy a new server, roll out a patch, turn on a new feature, have an engineer doing break-fix work in the service, you're introducing anomalies. And so you get to choose whether you're going to look at the top 10 anomalies, the top 50, the top 100, but it's all about where you draw the line. Furthermore, when you have anomalies, they don't tell you whether they are malicious or benign. They're simply anomalies. And so it's up to the operator to try to gain enough context about the system to determine whether this represents an indication of intrusion. Furthermore, when we bring in our red team, we discover that they don't introduce meaningful anomalies. Maybe their activity is in the top 10 or the top 50 hits for that day, but how do I know that this day is special and that one of those top 50 hits should be looked at with more scrutiny or is somehow quantitatively different than those top 50 hits on the other 364 days? So on my team, we switched from an anomaly-focused methodology to a threat-focused methodology. And what this means is that we've studied the work of Dr. Edmund Lacard, He's the father of modern forensic science. And his insight was that every contact leaves a trace. So this means that if I'm a physical threat actor, I'm a criminal, when I enter a crime scene, commit a crime, and leave, some of me is left behind in the crime scene, and some of the crime scene is left behind on me. And it's the job of a forensic investigator to study the crime scene and study me to put the link back together. And so just like a forensic scientist, when we understand threat actors, we take their techniques and we replay them in our own environment, looking for the evidence that these leave behind. My team builds sensors to pick up that evidence. We run that evidence through an expert system that applies rules based on what we know to be true or false about the design of the service and the activity of threat actors and the evidence that they generate. And that generates alerts, facts about adversary behavior that my engineers look at, not operators that live in another building, not analysts, vendors that we employ. This is my team. And so we have a virtuous cycle where we understand adversaries, bake that into our security agents, and then look at the output and tune our expert system with what we're learning. Now we also take that sensor output and we look back at the service and say, how can I improve this service to give me a better signal-to-noise ratio, to make my service more difficult to penetrate, or to increase the time that it would take an adversary to move laterally. So in practical terms, what this means is that we defend SharePoint Online with a custom security sensor that augments the built-in security auditing that Windows already gives us. It collects additional evidence from activities that threat actors are likely to do. We're monitoring for things like process and network activity, threads being created in another process by a parent process that does not have a relationship with it. We're looking for PowerShell, WMI, strange DNS activity, all of this in real time. We're taking point-in-time snapshots of critical machine state, like the auto-start entry point registry keys. And we're doing real-time analytics in that agent to alert right away if we see a high-fidelity indication of compromise. Now, this generates a lot of data. It's 6 terabytes a day from our production environment. We upload that to a big data system that we call Cosmos. It's very similar to Azure Data Lake, if you've seen any of the talks on that. We store this data for a year. So you can do the math, 6 terabytes of data, 365 days, and we run batch analytics across it to detect historical anomalies, to look at anomalies between one machine and the others that are like it, and to evaluate these facts that our sensors are giving us against what we expect an adversary to do. Now it's interesting, I don't have a spec that tells me what each of those registry keys should look like. But I do know that all of my machines should look exactly the same. And so one of my roles is that I can use the homogeneity of the data center against my threat actor and say, if you didn't compromise each of my machines in the same way, you're going to stick out. And it's true, that's an anomaly, but it's more than just an anomaly. It's an anomaly that's interpretable because I'm specifically looking for activity that I know might be related to adversary persistence. And so I've solved the interpretability problem that pure anomaly detection would otherwise have. Now, detection is just the start. Let me show you what this looks like. Here's my engineering team. We take in external breach reports. We take in red team input. We do our own research, our own experiments, and we encode everything that we know about adversaries into our custom security agent that's deployed on every machine in SharePoint Online. These sensors upload 6 terabytes a day to our custom security system, this big data system called Cosmos. We run batch analytics across that Cosmos output through an expert system that returns alerts to my engineering team. There's that virtuous cycle that I mentioned. So if I were to introduce my red team, they spend months studying our system, they find a way in, they get their tools, their malware, onto a machine in SharePoint Online. Now, I don't go peek at the red team's source control repository and learn what tools they're using. But I do know that they're supposed to be using tools that are similar to what real-world threat actors use. So I may not detect everything they do, but I'm going to detect some of it with my security sensor. My sensor is going to label that data, send it up to Cosmos, send it through my expert system. I will receive an alert. And when I receive that alert, I'm going to evaluate it in the context of what I know about this kind of activity and external and internal breach reports. Now next, let's say I found a piece of malware. My job is twofold. One, I need to hone in on this adversary so that I can monitor them in real time, while at the same time understanding the root cause that allowed this adversary to get in the first place, so that I can make a change to cut that off and terminate my adversary's access to the environment. So as I study the piece of malware that I found, I might find IP addresses or domain names, process names, thread names, things that the adversary is using inside my environment that are unique to him. I'm going to encode that information in real time back into my security agent through a cloud service. And now my cloud service is going to all pick up that information and start giving me real-time reports as this threat actor moves around my environment, as I see this IP address, domain name, process name appear on other machines. While I'm doing that, I've found the root cause, I've pushed out a patch, and I've evicted the adversary from my environment. And now I'm better off. A, because I have intel about this threat actor so that if he comes back, I have a better chance of catching him right away. And two, I found a vulnerability that I didn't know had existed, had the opportunity to patch it. So detection isn't the only piece of incident response that we have to be great at cloud scale. I also need to be able to do intrusion detection and response, which means eviction and investigation. So this starts with preemptive forensics. If I have to run a script across tens or hundreds of thousands of machines in order to gather forensic data when I have evidence of a breach, then I'm going to move much more slowly than my adversary. So instead, why don't I gather this data every day, all the time, put it up in Cosmos so that it's there, it's ready for me when I need it? Ironically, this is where our initiative to start recording all of the ASAP registry keys started from. And then we realized once we're gathering all of this data, that it should be homogeneous, that we can build detections on it. And so there's a virtuous cycle here again, from preemptive forensics back through detection, which turns into cloud protection. I also need to be able to investigate at scale. So if I find a piece of malware, I want to know where else it is in my environment without playing the for each machine 1Z, 2Z run a script game. So in order to ask these questions of the environment at scale, I need to instrument my cloud sensor. I need to have a cloud service that I can give questions to. And these questions are things like, does this pattern of bytes run in memory in any process running on your machine? Do you have a file with these attributes on disk somewhere? We use an industry standard open source toolkit called Yara to write these signatures and run them across our environment. And this allows us not only to hunt and to find threat actors that we believe are currently present, but also to take breach reports and the signatures that are present in those and run them proactively in our environment to ensure that that threat actor is not present. And then I mentioned real-time visibility. This is the capability of giving my agents an IP address, domain name, machine names, process names, and having them alert if they see those in real time. Now, having big data and big data analytics means that I can do big data visualization. So this is a real visualization on our production data set of processes making outbound requests to external network locations. The gray circles are processes. The colored boxes are different types of network destinations. All of these edges and processes contain metadata, such as the amount of bytes that were transferred, how many machines are making the connection. This is aggregated across over 100,000 machines. So I can quickly look for anomalies and sort by things like who's talking the most, who's receiving the most, who's sending the most unique connections, and how many machines is that happening on. The red edges represent periodic activity. These are network requests that beacon, that happen with a regular interval. And regular or periodic traffic is not malicious, but some malicious traffic is periodic. And so this is just another attribute that we use when we look at this data to help us hone in on the things that we should look at first. I love this because it represents the next step in the maturity model here. Right? We start with detection. We might try anomaly detection first and eventually come to an adversary or threat-focused approach. Well, once I can detect successfully, then I need to build incident response capabilities so that I can respond in real time at scale. But this allows me to hunt, which is proactively looking for evidence of a compromise that I didn't detect by looking at things that my adversary is likely to do. I'm looking for latent compromise. So if I were to rewind all the way back to my CSI forensic scenario, this is walking into an apartment that I own and proactively looking for evidence that a crime has been committed. I think it represents the depth of our commitment to protecting customer content that has been entrusted to us. Finally, our work here is externally audited to show that we walk the walk, not just talk the talk. So compliance is not a bolt-on in Office 365. It's a fundamental part of the service that we offer and sell. So accreditation against these regulatory compliance or security standards is part of our holistic approach to security and privacy. We do that to enable you to onboard to the cloud securely without giving up any control or any of the regulatory standards that you had to abide by when your data was on-premise. And then we build controls for you as an administrator to use to help individuals in your organization remain compliant when they interact with your data. Now, at a nuts and bolts level, these audits are an independent validation of our security practices by external parties. They come in and look at our FedRAMP compliance, look at our ISO compliance, and they assess us on how well we're doing against those controls. Now, we have a dedicated engineering team that helps us with these compliance and these standards. They build an internal framework of over 900 controls that they then map out to FedRAMP, to ISO, to other controls, whether those are regional or United States specific. And then we, as a product team, leverage those controls to ensure that everything we build meets the same high standard. So I'm proud to say that Microsoft has one of the largest compliance portfolios in the industry across both Azure and Office 365. And this includes both industry standards like ISO and SOC 1 and 2, United States specific standards like FedRAMP and HIPAA, as well as regional standards like EU Safe Harbor and the European Union model clauses. Now, we go a step beyond simply going and getting audited to prove our compliance. We actually make these reports available to you as a customer because we believe in transparency. So if you browse to the Office 365 portal and go to the Protection Center, you'll see the audit reports for Office 365, for Azure. This includes ISO, SOC 1, SOC 2, our ISO controls and how we chose to test and implement them. We also go beyond that and give you our pen test summary, our progress against the cloud control matrix, and this is what it looks like. So I love this because transparency is one of the ways that we can show you that we're acting with integrity with respect to the security and the privacy of your data. We operate in a world-class manner. We have great operational rigor when it comes to our administration of the service and our ability to administer it without touching your content. And so this is another way that we can be transparent about that. So in summary, I talked about 5 things today. I talked first about the principle that your data remains yours in our cloud and how that drives the rest of our security and privacy investments. Next, I talked about how your content is protected in transit with TLS 1.2 and perfect forward secrecy. I talked about how it's protected at rest with BitLocker, with per-file encryption, with bring your own key, with layers of network and physical isolation. I talked about how we administer your content without access, about how customer lockbox allows us to take every action that we need in the service except accessing your content, and that you get to be part of the approval process for that. I talked about how our security is continuously validated, that our system of both continuous patching, that our system for intrusion detection, our system of red teaming to identify unheard of or unknown vulnerabilities, all adds up to industry-leading protection for your content. And I also talked about our external audit story, that we are not only externally audited and compliant, but that we're public and transparent about the results of those audits. As I put this deck together, I'm overwhelmed by the amount of work that the entire organization has done in OneDrive and SharePoint to protect your content here. I really do believe that this is the safest place for your data. If you're looking for more, one of the things I didn't cover is the admin controls that we give you to help your organization remain compliant. We have sessions on that throughout this week. We also have a couple of deep dive sessions on service security, one solely on bring your own key throughout Office 365, another one on how access control works in Office 365, this just-in-time access and customer lockbox notion. And finally, if you would like to build your own on-premise monitoring solutions that look at the activity that's going on inside of Office 365, you can do that as well using our management and compliance APIs. And that's the last talk on this slide. So that's me. I would really value your feedback. If there's something that you wish I had covered more, I'd be glad to dig into that. If there's something that I spent too much time on and you wish I'd skip past it, that feedback would be really valuable too. I have a few minutes for questions, but I know that the next speaker is going to want to come in and get set up. And I'd like to take more than just the 10 to 15 minutes that I have. So if you're willing and you have questions, I'd love to meet you outside the room, and then you're welcome to ask me anything. So I'll be out there in about 2 minutes. Thank you, guys.